Okay, welcome once again for the next video. This next video is going to take us through the derivative of cosec x from first principles. Without wasting a lot of time, we shall say y plus delta y is equals to, remember, maybe before I bring in this, cosec x is also as good as the reciprocal of sine x. That is why I've written it as 1 over sine x. And so from this time, I'm now going to take a small change on x also. So I will have 1 over x but plus delta x. The next step will be making delta y the subject. And so it means delta y will be 1 out of sine of x plus delta x. But remember, we have to subtract y, which y is 1 over sine x. So I'll have 1 out of sine x. 1 out of sine x. Good. The next step is going to be the LCM as we did in the previous video. So I will have the product of sine x plus delta x and the sine x as my LCM. And from this level, now I can simply have the numerator as sine x. This will be sine x and minus sine of x plus delta x. There we are. Now when you look at the numerator again, you realize we have sine of a given angle minus sine of another angle. So that takes us back to factor formula. The factor formula in this case is going to be the one where we had sine A minus sine B as 2 cos A plus B out of 2 sine A minus B out of 2. So it means I'm going to take our A to be x, so it will be 2 cos of x, but I'm adding plus the x plus delta x, all this divided by 2. Then I now say sine, I beg your pardon, that will be sine of x, but minus x minus delta x. All this divided by 2. All that divided by 2. So from this level, of course, I have to remember that I have a denominator, which is sine x plus delta x multiplied by sine x. Multiplied by sine x. Okay. Now, from this point, I'm now going to simplify the numerator. And as you can see, x plus x is 2x. Divided by 2, I get x. So I will have delta y as 2 cos of x. But remember, we have delta x there, divided by 2. Then we have sine. X minus x will give us a 0 because x and x cancel. Then we have minus delta x, but divided by 2. Divided by 2. All this we are dividing by sine of x plus delta x, then sine x. There we are. There we are. And then from that point, we shall now remember the fact that sine of negative delta x out of 2 is as good as a negative sine of delta x out of 2. So that negative, we can transform it to this position so that we have minus 2. So we shall have minus 2 cos of x plus delta x out of 2, then sine delta x out of 2 out of the same denominator that we had in the previous step. Now from that point, we can now bring in the assumption that for small angles, we expect sine of delta x out of 2 to be approximately delta x out of 2. To be approximately delta x out of 2. So that now we have delta y equals to minus 2, the one that we have here. Now the whole of this is approximated to delta x out of 2. So we have delta x out of 2 there. Then cos of x plus delta x out of 2. All this divided by sine of x plus delta x, then sine of x. Now from this level, we can see that the 2 can cancel with the 2. So that we have delta y is equals to minus delta x cos of x plus delta x out of 2. All this divided by sine of x plus delta x, then sine of x. Now the next step is going to be dividing through by delta x, both sides. Dividing through by delta x is going to be the next step. So it means we shall have delta y out of delta x equals to, now it is going to be minus delta x cos x plus delta x out of 2 divided by sine x. This is out of 2, good. So divided by sine of x plus delta x, then sine x. So we shall now also divide this side by delta x, and that is as good as multiplying by the reciprocal. Delta x can now cancel, and you can realize that we have delta y out of delta x as negative cos of x plus delta x out of 2. All this divided by sine of x plus delta x, then sine x. So now we say as delta x tends to 0, delta y out of delta x tends to dy dx. What does that mean? From the previous step, our delta y out of delta x has now tended to dy dx. Just tended to dy dx. So I will have dy dx is equals to, now it is going to be minus cos of x. Remember we had cos of x plus delta x, but delta x has tended to 0. Divided by sine, instead of sine x plus delta x here, I will have only sine x, but multiplied by another sine x from the previous step, simply because delta x has tended to 0. And that means now that we shall have negative, I can say cos of x divided by sine of x. Now this will give us cot, but also we have 1 here divided by sine x, which is going to be cosec x. So it means in conclusion that dy dx is going to be negative cosec x. Cosec is obtained from 1 over sine, then cot x. So this brings us the end of the derivative of cosec x from first principles.